Hello, everyone. Welcome to ChefConf 21 Online. My name is Alan Baptiste. I'm the Product Marketing Manager here at Chef Progress, and it is my pleasure to be moderating the session today, where we're going to talk about Chef Inspect at scale, how automated compliance scanning as a hyperscaled workload at SAP. I have the pleasure of having two SAP technical experts. So we're going to go deep down into the nuts and bolts and what everybody's been interested in hearing more about, because Jay covered kind of the business case also from SAP in that story, and he referenced this session. So hopefully you're getting some great insights here. If you have any questions during the presentation, since this is being pre-recorded, we invite you to attend or post your comments and questions on our Chef Slack community channel. So make sure to go there for interaction with the speakers, with the chef experts as well. So without further ado, Tim Jones and Joe McRae, why don't you introduce yourselves and take it away? Thank you.
Hi there, Alan. Thank you for that intro. My name's Tim Jones, and I'm one of two people presenting today. Joe, do you want to say something?
Yeah, thanks very much. It's a pleasure to be here. So yeah, we're coming today from the SAP Cloud Security teams. I'm one of the DevOps engineers there, and Tim is one of the product owners. So yeah, excited to be here.
Yeah, thanks. Yeah, so as Joe said, I'm the product owner for who works for the multi-cloud security team, and today we're going to show you some of the methodology and techniques that we've used to actually be able to run Chef Inspect at the scale that is SAP, because that is it's a problem level of scale. So I'll get straight into the agenda here. Initially, I'm going to talk about the why we needed really to use the technique that we're going to show you, instead of just running SAP Inspect on a laptop or something, or a VM. We couldn't just do that because of our scale. So I'll get into that, and then I'll show a very high level description of how we went about scaling the Inspect workloads, and then I'll hand over to Joe at that point, and he's going to go through some slides where he'll show you how we've done it, generally speaking, how we've done it, and then also demo it running, and that'll be the talk end to end, really. So yes, but why do we need to do things this way? I mean, Jay in the twin presentation has gone into the why at a business level. So we've got that far. We want to use Chef Inspect because it's shift left DevSecOps, compliance as code functionality. But how do we do it at the scale that is SAP? Because SAP is enormous. It's really staggeringly massive, actually. The technical landscape, the cloud landscape across the globe is enormous, and we use 4 hyperscalers as well, the big American 3, and then Alibaba in China and APAC. It's across the globe. It's 100,000 employees. So we've got a real scale issue, and actually anytime we try and use anything new, the first question everybody asks is, can it handle scale? Because it's almost always the first thing that trips us up when trying to deploy something new is the scale. So yeah, I mean, this is very in reference also to Jay's presentation, but yeah, when the project started, we had 1.8 million resources, cloud resources, and by cloud resources I mean like a bucket or a VM or a security group or something. That was when the project started, and during the time of the project, it's grown to 13 million, which is a staggering growth, and it just shows how future-proof we really have to be. And the scale, when we started, the scale was pretty much unheard of, and now it's way more than that. And the rate of growth is pretty staggering. And yeah, we obviously need to be able to. We had to develop a system which could be future-proof to this kind of scaling. How can we keep up with scaling moving into the future as well? And the way we've generally gone about it is essentially to containerize the Inspect workload in a Docker container. And the Docker container is, for people that are familiar with containers, they're self-contained pieces of like mini OSs, and they have all the tools installed and things like that. And our Docker containers have the Chef Inspect toolchain installed along with the dependencies that we have. So in our case, that's the resource packs for we'll just use the AWS as an example. So that will be the AWS resource pack as a dependency. Any other like Ruby dependencies, any other dependencies that you need to actually execute the Chef Inspect tool itself. And crucially, the controls. So we have an external group within SAP called SAP Global Security, or SGS, who actually develop the policies, and they mandate the policies out to us, who are in charge of implementing them in Chef Inspect. And this is the workflow that we're using, implementing them in Chef Inspect. And then we bundle them into that same container. So the container becomes this self-contained executable, which is bespoke to our set of controls that is actually mandated by our security policy writers. So it's nice and self-contained, and the execution of the container is by design is stateless. So really all you need to provide on input is the auth credentials for an automation account, like a service account or something, to the target account that you want to scan, and then it runs. So in AWS, you provide the 2 AWS environment variables, which I forget name now, secret and something else secret. So you do need to have credentials to scan the account, but they only need to be read, because what it's doing, well, everybody knows, I guess, how Inspect works, but it's reaching out to the, well, this is the resource packs. Actually, the resource packs are reaching out to the APIs of the cloud accounts to determine and to look at the metadata to determine if the control is compliant or not. At least that's the way it works with those resource packs, and I guess other resource packs do things differently. Anyway, the output of the container is a CLI, JSON, HTML, or JUnit, just like a normal Chef Inspect scan. If you want to programmatically consume the output, you can, if it's JSON, or if you want to integrate with CI/CD, you can use JUnit. So it's that's the way it's run. And the actual overall method that we've used, yes, we're the cloud team. Yes, we are in charge of the visibility for cloud compliance across cloud security compliance across the business, but the method is actually agnostic of this fact. It doesn't care that we're a cloud team. It can actually run any set of controls. So this method that we're going to show you is portable to a lot of different use cases. So hopefully, like, useful to the viewers of this video in different ways as well. So, and as it stands, this method is currently used to do daily scans. So to the whole landscape, the whole enterprise, we scan it every day, and then the output is aggregated and sent onto a different platform we have developed for the reporting. That's as it stands, and the ship is Kubernetes. I didn't put the logo on this slide, but yeah, we use Kubernetes to orchestrate all the workloads in the Docker containers. And before I hand over to Joe, I'll just show you some of the sort of statistics. So yeah, as I said, we currently scan daily 13 million or thereabouts cloud resources across all 4 hyperscalers, and across 12,000 odd cloud accounts. The actual scan takes around 3 to 4 hours to run, which is kind of amazing in its own right, just the facts when you think about the scale. But the coolest part about this, I think, is actually that the hardware, or the virtual hardware that's needed, is actually comparatively modest, really. We have currently in our Kubernetes cluster, we have 3 nodes, 30 pods for each hyperscaler, so 120 pods. The account scan jobs are all queued up, and then the pods, they sort of take one job off of the queue and run it, and that's the way to do it. And 24 virtual CPUs on the nodes with 96 gigabyte of RAM at a cost of less than $4,000 US a month. So given the scale, like 13 million resources, just as a reminder, it's actually kind of cheap to run, really, and you don't need much in the way of virtual hardware. And moving into the future, we can add nodes fairly easily if we run out of headroom. But as you can see, 3 to 4 hours a day, there's 24 hours in a day. We've still got a lot of headroom to grow. So that's my piece. So without further ado, I'll hand over to Joe, who's going to do the next set of slides. Joe?
Yeah, thanks very much, Tim. So I'm going to take over for the technical side of the tutorial. So if you don't mind swapping over the next slide, Tim. Yeah, so first of all, we're going to look at when it comes to containerizing Chef Inspect, we have to first look at passing credentials. So string-based access keys, like the type that's used for AWS, Azure, Alley Cloud, they can just be passed as environment variables at runtime. It's slightly different for GCP as it uses a JSON file. So we'll actually show you how to mount that at runtime as well. So when it comes to executing inspect, it remains relatively similar actually. So if you only need CLI access, you can just run the container interactively and see that output. However, if you're looking into exporting the results for something like CI/CD usage or something like that, we may want to export a JSON file or JIT, HTML, whatever. So we're also going to take a look at doing that inside a container and getting that to output to the host as well. So the next slide, we're going to first look here at setting credentials. So as I mentioned, there's two different types of credentials here that are mainly in use. The top example shows how to pass those as environment variables. So that's, relatively simple. It's just passing your access key, secret access key, and then your session token if you have multi-factor authentication enabled. The second one then shows a Docker run, but instead passing in the JSON file at runtime. So that's used to authenticate with GCP. There we can set the project ID to tell inspect what to scan, as well as mounting the credentials on the run command. So what you do is you send the first section of that is going to be the GCP credentials location on your host machine or whatever is hosting this to run it. The second one then is going to be a predefined location in the container that inspect expects to pick those credentials up from. So with that, setting credentials can be a wee bit complex, but with these commands, it should sort of steer you in the right direction. If we just move on to the next slide, please. So yeah, this is just looking at a Docker file. So in this, we use a two-step build process. So first we build the image. We then create a tar version of the profile, and then we discard that image just to keep it so that we have a lean worker image that kind of actually performs the scan. So then we pick up that profile again. We copy in some assets, which I'm going to show you in the next few slides. We accept the Chef license, and then we start calling a script, which I'm also going to show you in the next few slides. Next slide, please. So yeah, this is the wrapper that I just mentioned. So this is what's called at the very, very start of our Docker run command. So what this does first is it renders some templates, which we're going to show you in the next few slides. So it uses ERB, which is a templating, templating language, but we'll show you that in the next few slides how that works. Secondly, once we have rendered out these files, we would execute inspect by attaching them there as arguments. And then finally, we would just clean up those files that we've just created. So in the next slide, we're just going to show you then. So this is an example of one of the ERB templates that I was talking about. This one renders how the inspect config is set out. So for example, here we would pass JSON out as an environment variable. And what that environment variable will contain would be the location where we want to output the JSON file to. So as you can see, it runs some if statements. So it checks that the environment variable has been set. If it isn't, it ignores the JSON and doesn't add that as a reporter. If it does, it'll add that in. And then obviously at the file location, it'll specify what you've passed as the environment variable. So at this point, you would also be able to pass things like waivers. So you could do the same thing with those. It would follow a similar pattern, and then you would just have that added into your inspect wrapper. Next slide, please. Yeah, so this is the overall profile structure. I've kind of laid it out like this to show you what comes standard with inspect versus what we've added. So everything in white comes standard with inspect. You have your profile, which contains a controls directory, a readme, and the inspect.yaml. So in total, what we've added here is a Docker file, which has been shown to you in the slides, as well as some assets, which we've also shown. So I think next I'm going to take a look at actually running the demo. So let me take over for the screen share. Perfect. So for our first example here, or for example, sorry, I'm going to show you a demo control. This one just basically checks that we don't have any publicly accessible buckets on our GCP account. So by doing this, we would check the IAM policy linked to that account, or that's binded with that account, and we would check that it doesn't match all authenticated users or all users. I'll kind of explain this over on the GCP console. So this is the demo bucket that I've created today. It's a pretty standard bucket. It's set up with not public access. So kind of what I explained here, we need to check that the bucket's policy doesn't grant access to all users or all authenticated users. So in principle, that would be non-public. So I'm actually going to show you then how to run and build this. So first of all, we would move into this directory that we've created, which will be distributed. Within this, it gives you the example profile with the Docker file, so you can build it yourself. But here we would run a Docker build. We're going to call this chefconf 21, and then we would just pass it to the Docker file. So what's going to do is it's going to run through this Docker file. So as I say, it's going to build, generate up the profile, then create this lean worker image. It's going to go ahead and pull in that profile along with some other credentials. It's going to set here the environment variable to tell it this is where we expect the credentials to be. This is not baking it into the image or anything like it. This just sets at runtime. This is where we're going to have the credentials, but I don't actually put in any credentials here. So we'll just let that run for a second. It built really fast when I was demoing this earlier and I was running through. So of course it's taking its time this time. Oh, there we go. So now we've built this image, we can do Docker image list. And we can see that this is the image that we've just built here. So running this, because it's a GCP image that we're going to be demonstrating today, I'm going to have to mount the credentials, which I'm going to do at runtime, of course. So I would do that by doing Docker run. I then pass the -v command as I want to mount a volume. This one, I'm going to just mount some demo credentials that we've generated up for today. So like that. So this is the location on my machine. But then I'm going to do a colon, a slash, and then the credentials that we have set for the location inside the container. So that is going to match up with where we're telling it that we're going to mount the credentials. So when it comes to running, it's going to know where to go to pick those up. We can then pass the GCP project ID, which is set as an input here. So let's just pass that. This will be unique to your project, obviously. This is just a demo one that we've set up for today's demo. And then finally, you just pass the name of your image. So we're going to pass this one today. So let's give this a run. We should hopefully see a pass. As we see over here, the bucket is not public. So we would hope to see, oh, whoops, my bad. I've put in the wrong name for the account. Yep, so there we can see that it's checked the IAM policy bindings, and it's found that the all authenticated users and all users count is 0, which is as expected. So as you can see, our bucket is past the test of being private access and not public. So yeah, that's pretty much all from the demo for me.
Okay, so everyone can see that slide, I'm assuming, and thanks for that, Joe. So yeah, you can see, I expect the delay in it was because the bandwidth was being used for the recording, maybe. But anyway, it was goes to show the method we're using. Also, it's interesting as well, I noticed while you were running through that the Docker file that we showed in the slide was like a simplified version of the Docker file we're actually using. We're using slightly more commands in the Docker file that you showed in your demo, Joe. And I think that was because we didn't want to use root inside the Docker image. I think that's what those extra lines are for. Yeah. But it's a great demo. Thank you. Let's go. So yeah, just to sum up now, really. So yeah, we've talked about how the scale issue is always a problem, and we decided to go about the security compliance. We had to get on top of the security compliance in the company for cloud pretty promptly, because we already had a lot of cloud accounts that we needed good visibility on when we started 2 years ago. And as you can see, in that time, there's been this enormous growth. So we did need to choose something that solved our problem back then, but also now is future-proof to just insane level of scaling as well. So we talked about how we Dockerized it and then ran it on Kubernetes to satisfy that scale requirement. And Joe showed you how to do it, basically. And you can take that technique and put your own controls in it, and your own resource packs, and run it on things other than the cloud as well. So it's a cool technique. We're pretty proud of it. It runs successfully every day, like I say, scans a lot of accounts, and yeah, it's good stuff. So thanks for listening. And if you want to reach out for any extra chat or questions, of course, here are our email addresses. And I believe Joe will be sharing a GitHub link as well for some demo code.
Great information, guys. Appreciate it. I have a few questions that come to mind from the presentation. This is kind of an end state that you guys have already. Obviously, kind of a situation where you've had a journey, right? You've started in a place and you explored and you've implemented. One thing is, from the early days, how was the kind of learning curve? Was it something that required a lot of effort, or was it pretty straightforward? Kind of, what's the learning curve on this?
Sure, I'll go first, Joe, if you don't mind. I mean, my learning curve, it depends on your background. I mean, if you're a DevOps person, the Chef Inspect approach, because of the compliance as code, just kind of makes sense. And it was mostly can I write Ruby or not? And even that, I actually hadn't written Ruby before, so I did have to learn a bit of basic Ruby. But yeah, it fits naturally into the DevOps workflow, so it wasn't too bad really for me. What about you, Joe?
Yeah, so my background, I'd done a bit of Ruby, so I think writing controls and stuff, it was kind of just a version of that, so it was fine. Yeah, I think when it came to sort of like figuring out how exactly we're going to do it, we spent some time sort of architecting out our ideas. But I think when it came to actually picking up things, there wasn't really anything too complex when it came to, learning curves. Obviously, with like anything, there's a learning curve just to learn exactly how the product works. But yeah, I think everyone felt pretty comfortable with it pretty quickly.
Cool. One thing I wanted to also ask is, so was this the containerization of the solution and the scalability of it and where you took it? Was all this kind of in your mind already when you started the process and the project, or was it kind of an experimentation here and let's learn a little bit and kind of growing that concept? Was it? Well, did you set yourself, what I'm saying? Did you set yourself with the idea of this is where I want to get to, or was it kind of a let's learn along the way?
Well, I mean, broadly speaking, I had a background in Kubernetes, so I aimed for this mostly, but of course, along the way, we ran into roadblocks that I didn't know about, and I guess the same would be for everybody else. So obviously, we've been learning a lot along the way as well. But broadly speaking, the containerization of it was the intent from the start of the project. Yeah.
Okay. Well, speaking of which, learnings, are there any tips and any suggestions that you have for people that are kind of considering using Inspec in this scale?
I think maybe, first thing that springs to mind for me is making the containers stateless made it a lot easier, like actually to the point where it actually made it possible. If we'd have had a stateful container, obviously would have been way harder. I mean, that's my first instinct. Joe, do you have anything to
add? Yeah, I think one of the things that I think kind of can do you well is just the ability to the debug. So we did a lot of debugging where it came to deploying it and kind of setting how we expected it to run, figuring out exactly how the debug tools work with our specific instance of Kubernetes. So I think that definitely helped quite a lot when it came to figuring things out along the way. As we hit those roadblocks, because we'd kind of mastered the debugging tools, we were pretty good at figuring out, it's things like Pry for Ruby that none of the team really have much experience in. So we had sort of picked up things like that really helped us.
Yeah, and another thing that's I thought of actually more of a workflow thing. I think we've learned more recently, and that probably wasn't part of the original plan, was how to integrate less technical teams like the policy writing team into a very development style DevOps workflow. We have actually got there very recently, and actually I think we're really benefiting from it now. But of course, there is that sort of, you have to basically educate them. But we have got to a point now where the policy writers review the controls on GitHub PRs, and so the workflow works really nicely now. But it takes a while to get there. Depends obviously who you're partnering with in the business and what their technical background is.
Yeah, I think that's the beauty of Inspect, is that's a human readable language. As long as the teams that are using it start to understand the let's say the syntax, if you may, the structure of it, then it starts to make a little more sense to non-text.
Absolutely, yeah. The DSL, the domain specific language, is basically just English. It is great, and it's very easy to convince people it's a good idea when you show them one, and anyone can read it. If you can read English, you can read the control. For us, it was more training peer teams on how to use GitHub than it was to how to read the Ruby.
Yeah, great point. So were there any surprises, pleasant or otherwise, in this journey?
I'll think about one for a while. Joe, do you have one?
I can think of a good one actually. So the day that we finally released to production, I think we all kind of sat in standby expecting something to go wrong. And maybe after an hour or so, everyone kind of started to think wait a minute, there's nothing, going to come out and bite us.
There's no
here.
Bells, no whistles,
yeah,
no red lights. What's going on?
So we had the whole team on standby, I think, for nothing really. Everything kind of went pretty smoothly with it. I think we were always expecting some thing that we hadn't thought about to coming back and bite us, but I think thankfully we
yeah, that's
avoid
true.
that
I mean,
one.
it worked better. It was, containerizing this. I think for going back to my memory of the early stages of the project, it made sense to me to containerize this workload. But now, looking back at the experience, it was such an appropriate use case for containerizing it that it worked out better than I thought it would actually. Yeah, and going back to the hardware requirements, or the virtual hardware requirements, it's very modest, but you couldn't really, I don't think, go to that scale really with any other method that I know of, modern day method. I mean, you certainly can do it with VMs, for example. So yeah, it's worked out very well.
Yeah, to me, the what's most impressive from an outsider's perspective is just the scale, the magnitude of what you guys are doing there at SAP is just amazing, right? And still growing too, for that matter.
Yeah.
And even when you started at 1.8, million instances, that's already, mind-boggling. Now you're going in the tens of millions. It's just insane. It's just amazing. So
yeah, just a lot.
More impressive. Closing thoughts, suggestions to who's starting this journey. What are some of the tidbits that you would like to share to teams that are starting their journey with Inspect?
For me, Joe, I'll give you a turn in a second. I mean, I would say that, remember what we've shown you is we're a cloud team. We scan clouds, but the method is totally universal. In fact, to the point where we actually have architected a Kubernetes cluster to scan cloud that we could actually lend to any number of our colleagues to scan other stuff if we it's so I guess take what we've done and play around with it, see what kind of scale you can achieve. Yeah, that would be my closing thoughts. And what about you, Joe?
Yeah, I think just the only thing I would say is just like, have patience and architect it and see what works for your business. Because obviously, at SAP, we work in a certain way and our teams are laid out in a certain way, and it's just the way we function. But yeah, I think it's one of those things where you can be patient, figure out what works best for you, and go from there.
Great. Thank you, gentlemen. Thank you, Tim. Thank you, Joe, for this time we spent here, and hopefully this was informative to those that are watching this. Remember that if you want to comment or ask questions at any time, if you're watching this during Chef Conf or after, the Slack community channel for Chef is the best way to communicate with community members such as Joe and Tim, but also with other experts that are participating on that community channel. So once again, gentlemen, thank you so much for your insight, for your feedback, and hopefully everyone is enjoying Chef Conf 21 online.